Welcome to this XARM robotic arm assemble and operation guide. Objective: the study of robotics, including the application of robots, manipulation of robots, design of robots, and the fundamental research of robots. Having a robot arm can help us to study the manipulation of robots, sensor servo architecture, and the study of kinematics. There are some limitations though. The research of robot may be hard to explore just by using robot arm. But here, this application of robot, manipulation of robot can be demonstrated by a robot arm. All the robot information that covered in this course are obtained from the robot manufacturer directly, with their consent to use them for educational purpose. This course designer has no personal connections with the manufacturer, nor will we promote the sales of the product. The robot arm is chosen mainly because of the budget, ease of use, and the robust features. XARM. The robot that we use, XARM, is a low-cost solution. If you purchase it from Amazon or some website, it is only about $200 currently. And it has 6 degrees of freedom. So you can see there are 6 servos. 1 servo over here for rotation, 1 servo here for this arm rotation, 1 servo over here, 1 servo over here, the other servo over here, and then there's an arm stretching over here. XARM is a programmable mechanical arm with feedback. It contains 6 serial servos, and each servo has 6 degrees of freedom. Each servo can display temperature, position, and voltage. Each servo has a RGB indicator to present the status of the servo. It supports computer programming control, mobile app, and the joystick control or mouse control, and can also be manually programmed offline. This XARM is accompanied by a secondary development kit, which contains more than a dozen of electronic module and structural components. This is the secondary development kit. When we put them over here, and it's connected by certain serial bus, and your controller is over here. So basically, it creates a feedback system, sensing, processing, and then send back to the control. So this one can demonstrate the servo and the sensor structure. Try lab. This course may be broadcast or delivered online. In an online environment, the lab work is hard to do if you just want to have the physical robot. So we designed some dry lab based on this XARM, so students can actually use the proper programming interface to design C program, and also may be able to use this C programming interface to develop some model. And those models may be simulated in Python first. XARM's feature. It used 6 serial bus servo LX15D. And this kind of the servo has full metal gear, high precision imported potentiometer, torsional force, precise angle, and many other features. And it used a Arduino core CPU built with Bluetooth module and 16 megabit storage memory. And it has very simple wiring scheme, basically directly connect 7.5 volt DC power adapter, and it has good suction cup design, even though we can actually tie this robot arm onto a robot card. Various programming and the controlling methods. It supports mobile programming, computer programming, offline manual programming, and mouse, and many other ways to control it. And it has the extensive developments support for secondary development using Arduino And we can also find rich tutorials. This is the whole set of the XARM before example. It includes a chassis, some rotor, and some servo, and a control board, and a few accessories. XARM assembly. When we first look at this box, we open it, you will see a user menu over here, and you will see a remote control and a USB interface core over here, and there's a chassis and assembly parts over here, and you will also see a few servo over here, and then there are arm bodies metal here, and then there is a controllable over here and a power supply over here. First, we should install the base and the rotor. As you can see, the metal rotor frame over here. When you assemble it, make sure that your nuts and bolts are put into a ball, something like this. And remember that put some major part on the table, but the tiny part, please remain on the box or put into the ball. And some cable can be placed on the table or desk. And you may need some tiny extra screwdrivers, and those may be needed. The official one is over here, but it's not enough. And you may also need a clipper, and you can use a clipper like this. After you complete the rotor and the bases, you should hook up the servo. And remember, the servo number 6 should stay at the base, and then number 5 will be on top of the base. So servo number 5 should be put on the rail over here, and your number 6 should be at the bottom, and it's going to be connected to the bottom plate. So these are very important, and remember that you also need to check the orientation of those USB and the signal connection wire. Where are they going to go into the servo and get out of the servo? If you do not actually set up the servo correctly, you may have to disassemble it and then reassemble it again. So these steps are really important. Even though the manufacturer provide a good video tutorial, but their marking for the servo number is wrong. So you must pay extra attention to take care of the servo number and the orientation of these servos. Now, servo 5 is going to be attached to the rotator and the chassis. After servo 5 and 6 are installed to the chassis and the rotator, now we are going to install the robot arm starting from the servo 5. So you must make sure that your servo 5 and 6 are on the chassis. Then we are going to install the one that connected to the servo 5. And also remember that you need to put the servo 5 in the right direction so that its connector can be shown as this. Then we connect the metal for the robot arm for servo 4 and servo 5. Servo 5 is attached to the metal first. Then the metal component for servo 4 and servo 3, and attach the servo 3 to it as well. Now we attach the servo 2 to it as well. It looks like an arm now. Section 3, XARM wiring. We attach the fingers and the control board, and we are able to use the USB port and connect it to the computer. At this moment, I did not fix the location for the control board, and we can still tilt it. And if there is something wrong, we can still move the control board. Once the control board is fixed, it is okay to attach the control board to the robot chassis. As you can see right here, Christopher is trying to fix the robot arm. He used his finger to tune it, and sometimes he used a clip to tune it. He's trying to loosen some nuts over there,
and sometimes you need to adjust to the right strengths in order to make sure the robot's performance is the best. And you also need to be aware of the direction of your wire and make sure it is in line with your connectors. And the chassis will also be fixed, and then later we will attach the suction to help it to be stabilized. At this moment, he's focused on tuning the first and second servo. Make sure they are well connected, and make sure the wire can help the robot to operate at the right function.
Section 4, Controllers. The controller is a processor-based stuff. So you can see here, you have a Bluetooth unit, DC power jack, and here you have another set of the VCC plus and minus. I believe you can connect the battery or some other voltage source to here. And you have controller switch. You have servo connection port. This connection port will be connected to the base servo, the servo 6. And then you have the run button, programmable button, and the interface to the secondary development kit. And it has the USB controller. This one will connect this board to a personal computer. And then there is a wireless handle interface. This is the outlook of a servo. And this servo actually is of 43.3 grams, and these are the dimensions.
Section 5, Software and Manipulation Mode. This XARM robot has 5 manipulation modes: PC touchscreen and mouse control mode, cell phone app mode, remote PS2 controller-like, but not the same. Actually, this one is similar to a PS2 controller, but it is not the same. So it is a specially designed remote control for this XARM. And we also can use PC program control, and also using Arduino embedded processor to perform control functions. So here, for the first one is the PC touchscreen control. Basically, you can use the software that's called XARM software, and you can actually show how to control it. So here, because there are 6 different servos, so basically here servo 1, 2, 3, 4, 5, 6 on the chassis. And each one of them has 3 different ways of controlling it. You have left and right, down and up, back and front, something like that. So here you have close, release. So release actually is used for the servo one, okay? So actually you also have left and right. Left and right actually is the tuning of the servo 2. And then servo 3, you have down and up. So down and up actually is the control for this portion. So basically here you have rotational controller, and here you have rotational controller. Here, over here, you have rotational controller, and here, basically, you have this way of rotational control. So there are several servos to help you to control this robot. So over here, the PC mode, you can clearly see how you can control it. And the release and grabbing mode actually is close and release is for this servo one. So this is a 6 degree of freedom robot. So right here, we have a similar controller using cell phone app. And left-hand side is the menu. And going to here, we can control the XARM similar to using the PC software. And cell phone tend to be the best control mode. So right here, you have 6 servo, and then you have different number about your close and release. So you can actually swipe your numbers and you will get it. So here, this one is for PS2-like remote control, and it uses a Bluetooth to talk to your controller board. And PC control software. You can also use a PC control software. You can actually write some action group, and action group is a software and you can actually use your PC to control it. This one is different from PC, mouse, or touch screen controller. Touch screen controller actually is directly manipulating robot, and this one we actually use program. So this one actually already give us some flexibility to be able to do programming and apply our robot model into it. And the last one is using embedded processor. You can use Scratch language or C language to program this Arduino. In this example, it's Arduino Uno, and there are several different Arduino models can all be used to control this controller. So in order to make the Arduino controller more efficient, there is a secondary development kit like this one. And as you can see right here, your controller being used to control it somewhere. And here you can attach the sensor. So sensor report the data to this board, and it forward to the controller, and controller send to the controller of the robot, and it control the robot. So the processor, it can be here. And you can also use a PC to replace this one. So you can actually use your personal computer somewhere here, and then the feedback signal go into PC and then go back to the controller over here. So either you can use your Arduino embedded processor, or you can use your PC to work with this XARM. So here, totally, we have 5 different manipulation modes. All of them are very useful, and you can try on different operation mode. For us, as a robot control modeling and planning course, we will be using more on this PC control and also the embedded processor control. The program that we use using PC program or using cell phone controller, it is more convenient, but it's not the purpose of our demonstration. And also, there's one more thing I need to mention about is this robot also has the push button learning mode. So you can actually drag your robot to a certain location and then push the button, and the robot itself will actually record its procedure, and then later you can play the procedure and directly program it using the push button as well. This robot is self-sensing, so if there is some error, a beep beep sound will sound. Let's look at a default drill using PC control. Christopher operate more using mouse control.
Yeah, that's not cool. Let's try this one.
Now use the cell phone mode to grab the clip. As you can see right now, Christopher is operating his own cell phone and try to approach the clip. Now he get it. And then leave it up. He seems to have some trouble to control it. Now he's make rotation and then rotate back and then put forward. He will bring to himself and then move. He'll try to rotate his clip as well. And then he finally will drop it. Now, last demonstration. Pick up a toy and drop it down.
Toy. Go down, forward.
Section 6, secondary board, sensor and the display. So you can connect your controller with Arduino 0 or other Arduino model. Here are the cable connections. And we have another extension secondary development kit like this. So basically, the Arduino board will become a controller to control this secondary development kit. So basically, there are several modes to control this controller board. So basically, your robot is connected through this wiring to your robot arm, and you can use your PC to control it. You can use your wireless remote controller to control it. You can also use Bluetooth using your cell phone to control it. You can also connect your sensor to the Arduino so that your sensor senses something, send signal to the controller. You actually through the USB port to program the Arduino environment. So once you have some signal, Arduino will send the controller signal down to this board as well. So when you connect it, you will connect it to here. So basically, there are several modes you can do. You can have the servo sensor architecture using this Arduino board connection to here. Or you can use PC to go through USB port, or your wireless remote control, or your cell phone through Bluetooth. And this is the secondary development kit. So far we covered the overall lab material. And in terms of each lab or project development, we will have separate video to cover it. Thank you. Bye now.